something happened to the academic community that lost curiosity, the childhood curiosity. When we see something, I'm not talking about a hypothetical possibility of extraterrestrial objects being of technological origin. I'm just saying the first three looked weird. They look unfamiliar. And in fact, there was a paper in Nature last week, okay? And everyone jumped up and down cheering. Why? Because this paper said, oh, Oumuamua was just a water iceberg that we are familiar with in the solar system. And the reason it didn't have a cometary tail is simple. This iceberg made of water traveled through interstellar space and was bombarded by cosmic rays. And the cosmic rays broke the water molecule, which is hydrogen and oxygen, broke it into hydrogen, separate from oxygen. About a third of the iceberg broke into hydrogen and oxygen. And when it came close to the sun, the hydrogen evaporated, and hydrogen is transparent. It was actually a comet, but it's a dark comet. Dark comet is a concept that is basically an oxymoron, because a comet is defined as an object that has a comma around it. Open any encyclopedia and you will see that a comet is an object that has a comma made of gas and dust. Yet, this paper in Nature that was published last week said dark comet is the explanation for Oumuamua, an oxymoron. Just like in George Orwell's 1984 book, war is peace, ignorance is strength. Okay, and everyone in the mainstream said, great, now we have a solution. Not only the mainstream, but science journalists, like there were many articles in all the major newspapers saying, problem solved. Oumuamua was a water iceberg. Now, this paper appeared on Wednesday afternoon last week. On Thursday at noon, we submitted a paper to the Astrophysical Journal Letters showing that there was a mistake in that paper. What is the mistake? Energy conservation was not satisfied. This is a sacred principle in physics where all the atoms in the universe satisfy energy conservation. You can't say it's the opinion of one side of the argument to say energy conservation is not satisfied and another side says energy conservation is. No, physics requires energy conservation. It's not a political issue that two different opinions can be expressed and be equally valid, okay? Everyone practicing physics will tell you energy must be conserved. Now, what was the mistake? I can give an analogy. It's just like saying you bring a certain salary home and you say, okay, will the salary be sufficient to support my family? And you include only the rent and the utilities and you forget to include the cost of the food, okay? Then it wouldn't work. You can write a Nature paper and say my salary is sufficient to support my family, but if you forgot to include the food, you are wrong and you will be proven wrong in reality. It's not a viable solution. That's exactly the mistake that was made in this Nature paper. They said energy from the sunlight is hitting the surface of the iceberg, the water hydrogen iceberg, and it's being radiated back to space from the surface. So they balance energy in with radiation out, and they derive the temperature of the surface. And at that temperature, they show that hydrogen can evaporate and give you the boost necessary for the non-gravitational acceleration of Oumuamua. That's the paper. Now, what did they forget? They forgot the fact that in order to release hydrogen from the lattice, you need to invest energy. You need to release those hydrogen molecules from the surface. So that costs energy. When you put that in, you lose a lot of energy. Actually, it's a major component. And it turns out that the surface temperature is 9 times smaller than estimated. And by the way, when I say surface temperature is 9 times smaller, this term is almost 10,000 times bigger than the other cooling term of the radiation that they consider. So if it's 9 times smaller, it turns out that there is just not enough speed in the molecules of hydrogen that evaporate to push the iceberg to the acceleration that was observed from Oumuamua. It just doesn't work, okay? And so I wrote this paper a day after the Nature paper appeared, And I mentioned it to all the science reporters. And some of them, what is the answer? Some of them said, okay, we will incorporate that in our report. But most of them said, oh, too bad, but we don't want to confuse our readers. And I say, that is misinformation. It's not a matter of confusing the reader. In science, there is right or wrong. If you don't do the energy conservation correctly and you don't report about that, you give the audience the impression, problem solved, it's a water iceberg. It's not.